So alcohols. And as with the other general functional groups, we'll need to know the basic nomenclature, basic physical properties, and reactivity properties. So basic nomenclature for alcohols, they either end in the suffix -ol or take the prefix hydroxy. Now, when they take the suffix or the prefix depends on who is the primary functional group. So if the hydroxyl group is the primary functional group, it'll take the suffix -ol. Whereas if it's not a primary functional group, it'll take the prefix hydroxy. When it's the primary or not the primary functional group is beyond the scope of the exam. So you will not have to differentiate, for example, whether this is supposed to say to hydroxypropane or to propanol. Those are both going to be fine and indistinguishable for the purposes of the exam. You should just recognize the name when it's given and recognize that it is referring to a hydroxyl group. That is an alcohol. You may see the para, meta, ortho nomenclature, but I want to really emphasize the fact that you will not see aromatic chemistry. So you won't see electrophilic aromatic substitution, things like Friedel-Crafts alkylation, acylation. Even if they're in any other textbooks or other materials that you happen to be using, recognize that they will not show up on the exam. What will show up is very generic things about aromatic properties. So understanding that we have a lot of pi bonds here, and pi bonds can basically act as good nucleophiles. So these are generally resonance stabilizing. Very basic things on that level, but no very specific reactions like you would have covered in organic chemistry course or that is found in some MCAT materials out there. It's not in the syllabus, so you don't need to worry about it. In terms of their physical properties and their basic reactivities, so for their physical properties, they can form hydrogen bonds. And we'll talk more specifically about hydrogen bonds later on. Because they can form hydrogen bonds, hydroxyl groups generally add quite a bit to the boiling point, melting and the boiling point of molecules. If we look at the boiling point of butane versus 1-butanol versus 1,2-butanol versus 1,2,3-butanol, you can see that adding each successive hydroxyl group increases the boiling point quite substantially. So it does have a very notable impact here, and that again is due to the hydrogen bonds. Alcohol groups can also act as very weak acids. They are acidic because they can get deprotonated, but they're very weak acids. And so you generally need to put them in the presence of a very strong base in order to get them to deprotonate. Okay? So as we'll see later on, certain other groups on the molecule can enhance the acidity or hinder the acidity. Okay? Electron withdrawing groups will enhance acidity, whereas electron donating groups will basically nullify acidity. So we're going to examine that some more, specifically when we talk about carboxylic acids. Let's go ahead and try out this problem. We've talked about pKa before, so here again we're seeing concepts from general chemistry show up in organic chemistry. So try this one out and we'll discuss when you're ready. Okay, so with this problem, the first question we want to ask is, what does it mean to have a higher or a lower pKa? So let's examine that. Okay, if I have a high pKa, so a pKa that is big, does that mean that I have a high Ka or a low Ka? Remember, pKa is the negative log of the Ka. So what that means is, as the Ka goes up, as the Ka goes up, the pKa actually goes down. We talked about the pKa as sort of a measure of the strength of the acidity, sort of its intrinsic acidity. So when I have a low pKa, what that means is it's an acidic product. Okay, the lower the pKa, the stronger the acid. Now we can also think about that from the context of pH equaling pKa, right? The half equivalence point. Because we talked about how when the pH equals a pKa, you're sort of right at the threshold of mostly protonated or mostly deprotonated. So the stronger the acid, the harder it will be to get it to become protonated, because it likes to dissociate very strongly. And so you can have a very, very low pKa for a very strong acid, because it's really hard to get it to be protonated. So negative log of the Ka, the bigger the Ka, the smaller the pKa. So here, I have a pKa of 15.5 and a pKa of 15.9. The lower pKa is the stronger acid. So now, the next question is, if I have a strong acid, does that mean I have a strong or a weak conjugate base? Strong acid, does it mean it's a strong or a weak conjugate base? And the answer is that strong acids have weak conjugate bases, right? So methanol is a stronger acid, which means it has a weaker conjugate base. Stronger acid, weaker conjugate base. So the stronger conjugate base should be the weaker acid, and that is ethanol. Okay? Ethanol is a weaker acid, and therefore is going to have a stronger conjugate base. So my answer here is C. It's going to be the strongest base. Now, ethanol and methanol, A and B, are acids. They are weak acids. Okay? They can act as bases, but they are very, very weak bases. In order for them to act as a base, they have to accept a proton. And they're going to be very, very weak bases. They are actually, in fact, acids. Okay? They're weak acids, so their conjugate bases are very strong. We can't make the assumption, oh, something is a weak acid, therefore it's a strong base. No, it doesn't necessarily mean that's going to act as a base at all. Acid, there's the Ka, and the Kb are two separate questions. Remember, they deal with two separate equations. So they're two separate questions. Okay? Our answer here is C. In fact, since we have a very weak acid, we'll have a pretty strong conjugate base, and the ethoxide anion will act as a weak base, or will act as a strong acid, because ethanol it'll act as a strong base because ethanol is a weak acid. So specific reactions that we can get. We can get alcohols from various reduction reactions. Remember in Organic Chemistry 1, we talked about different reduction and oxidation reactions. Alcohols are, compared to a lot of other functional groups, pretty highly reduced. So we can reduce a lot of other functional groups to alcohols. Carboxylic acid can be reduced down to an alcohol. See, we're getting rid of the carbonyl, so we're adding hydrogen atoms, removing oxygen atoms. Aldehyde, same thing. Breaking bonds to oxygens, adding hydrogens. We can add water across a bond, in this case a hydration reaction, and this reaction is actually really, really similar to the HX addition, the hydrogen halide addition. So even the halogenation reaction that we talked about in Organic Chemistry 1, the addition of the hydrogen halide, has an analog with water. It's going to follow Markovnikov's rule. First, the proton adds, makes a carbocation, and then the nucleophile attacks. And the Grignard reagent, / the Grignard reaction. We're going to talk more about this specifically when we talk about ketones and alcohols, But for now, just know that Grignard reagents will produce alcohols. Oxidation reactions will make products more oxidized. So alcohol to an aldehyde is an oxidation reaction because we are adding bonds to oxygen, we're removing hydrogen atoms. Same thing happens with alcohol to carboxylic acid. Okay? Now, one thing that I think is interesting is that both of these reactants are ethanol, and I end up with either an aldehyde or a carboxylic acid, okay, using these different reagents. So same reactant, different product, both oxidation reactions. How would you classify the difference between PCC and chromate, given the difference in the products? What do you think? Okay, an aldehyde is less oxidized than carboxylic acid, right? Carboxylic acid is more oxidized, and so therefore chromate, we can deduce, is a stronger oxidizing agent. So that's something that you should be comfortable recognizing. Mesolates and tosylates are very interesting functional groups. These are groups that can be used often in drug synthesis as protecting groups. So they both act to, as far as we're concerned on the exam, do the exact same reaction, they just do it in marginally different ways, and of course they have slightly different physical properties. They both act as really good leaving groups. And so when I have, for example, tosyl chloride or mesyl chloride, and I add it to an alcohol, it basically replaces the alcohol group with the tosylate or the mesylate. And because they're really good leaving groups, it means that we can regenerate them at the end of the reaction. Now, often a question that I get is, well, if they're really good leaving groups, how are they good protecting groups? Because won't they just come off? They would if you have some sort of nucleophilic reaction, but that's not necessarily the only kind of reaction that you'll have. You know, a nucleophilic substitution reaction in drug synthesis. There's lots of oxidation, reduction reactions that can occur that might affect alcohols. There's a lot of very specific reactions. There's tons of different organic synthesis reactions out there, many of which are way beyond the scope of the exam, which have various mechanisms and that might not have any impact in terms of removing these leaving groups. So we can protect an alcohol from reaction, do whatever reaction we need to do, and then regenerate the alcohol at the end. One thing I also want to mention, just to make it easier to remember these names and the structures, you can think of mesolates as methyl sulfonic acid, SO3, and tosylates as toluene sulfonic acid, tosylate. So the names are basically just a combination of the two individual names.
For most students, and maybe you too, the CARS is the hardest section on the MCAT. It may feel like it's one of the few remaining obstacles between you and the medical school of your dreams. But as you try to prepare for the CARS, you find there is a never-ending stream of conflicting tips, strategies, and plans, none of which seem to actually help or show any results. If you feel frustrated, overwhelmed, or lost when it comes to the CARS, if you're looking for a CARS expert who has helped thousands of students achieve their MCAT CARS goals, then you've found your solution. Testing Solutions MCAT CARS Bootcamp. Founded by Nick Zahner, a current medical student at Stanford with a master's degree in philosophy of religion from Harvard, Testing Solutions' approach to the CARS is revolutionary. Testing Solutions CARS Bootcamp provides day-by-day, step-by-step instruction that teaches you the techniques that produce ultra-high MCAT CARS scores. Instead of wasting your time with the needlessly complex filler that other companies try to sell you, Testing Solutions' approach to the CARS is based on the principle of minimum effective dosage. There's no wasted time, just the minimum amount of effort that is required to get you the results you want. With over 500 4.5-star reviews on Amazon, Testing Solutions CARS Bootcamp is the most trusted, proven, and effective CARS course available on the market today. You will have access to Testing Solutions' 180 meticulously designed CARS passages, the largest CARS practice library offered by any MCAT prep company in the country. Our passages are regularly rated by users on Amazon, Reddit, and SDN as the most accurate non-AAMC CARS practice passages available, consistently rated higher than Exam Crackers, the Princeton Review, Kaplan, and Next Step. Unlike some companies who prey on pre-medical student fears by charging outrageous amounts of money for their mediocre at best practice materials and courses, Testing Solutions will always charge a fair price for an amazing product. Because after all, we're not like the other test prep companies. We're aspiring doctors just like you, only a little further down the path. Let us help you do what we've already done. If you're not happy with your CARS Bootcamp for any reason, we offer a 100% money-back guarantee, no questions asked. You've got nothing to lose and the CARS score of your dreams to gain. Don't be one of the people who write us each week saying they wish they had found our MCAT CARS Bootcamp sooner. You don't have to struggle with the CARS any longer. Sign up and get started today.